All right, this is topic 8, related rates, which is everyone's favorite topic, right? Yeah, right. Okay, so couple steps to remember when you're doing related rates questions. First of all, related rates questions are going to be those ones that involve using the geometric formulas that you've used. A lot of them are about ladders or cones, and I'll talk about that in a little bit. But it's going to have a rate that something is moving, and then it's going to also have some values that are staying the same. So what does this mean? Steps, number 1, you always draw a picture. Label, write down all your given information. Just put all the stuff that's in words, put it on a picture so that you can visualize it. Step 2, find an equation that relates the variables given and the variable that you need to find. So for example, if they give me the volume, they give me the radius, they give me the height, and it's a cylinder, I'm probably doing a volume of a cylinder formula, right? So find the formula that's going to relate all those variables. Number 3 is differentiate with respect to time. That's going to be implicit differentiation because you're going with respect to time, and you have a lot of variables like r for radius or h for height. Substitute givens and solve for the unknowns. So once you figure out the formula, this is pretty straightforward. Differentiate, substitute what you know, and then at the very end, don't forget to justify your answer using NUT. NUT is noun, unit, time, right? So we're going to use that in related rates. Let's try an example. It's a lot easier to just practice these. So a 13-foot ladder is leaning against a wall. Suppose that the base of the ladder slides away from the wall at a constant rate of 2 feet per second. How fast is the top of the ladder sliding down the wall when the base of the ladder is 5 feet from the wall? Alright, so let's draw a picture here. We have our wall. And we have a ladder on that wall. And here's my ground. Okay, so this ladder is sliding down. It's a 13-foot ladder. Is that going to change? No, it's going to stay 13 feet the entire time. So I'll put that 13 feet there. Then what else do I know? I know that it's sliding away from the wall at a constant rate of 2 feet per second. So 2 feet per second is my rate down here. I'm going to call it dx dt because that's my rate that the x is changing. So this amount down here, how far is that ladder moving out? That's going at a rate of 2 feet per second. And don't forget your units here. These are really important. And then how fast is the top of the ladder sliding down the wall when the base of the ladder is 5 feet from the wall? So they're also telling me that x here is 5 feet because my base of the ladder, how far is it from the wall? And they're asking me to find my dy dt, how fast, so that's a speed, that's a rate. How fast is this ladder moving down the wall? So find dy dt. Okay, so ladder problem, you should be thinking SOHCAHTOA, Pythagorean theorem, similar triangles. What are we thinking here? We have enough information probably for our Pythagorean theorem. Let's try it out. So Pythagorean theorem, we could use a squared plus b squared equals c squared. I'm going to use x squared plus y squared equals z squared. And keep in mind, z is that hypotenuse, right? So I already have the hypotenuse. I know it's not going to change. It can't change. So I'm going to put that in there. My x and y, though, that height and the distance on the ground is changing. So I'm going to leave that as x squared plus y squared equals 13 squared. Okay, so now let's differentiate this. We found the formula. Step 3, differentiate. So we have 2x, but remember I'm going with in respect to time, so 2x times dx dt plus 2y times dy dt is equal to 13 squared. The derivative of 13 squared is 0. Okay, so now I differentiated with respect to time. Now let's substitute the givens and solve for the unknown. So what do I not know? I don't know dy dt, so this is going to stay dy dt. Everything else I do know. So 2 times the x is going to be 5 feet, and I am going to put the units in there too. dx dt is 2 feet per second. plus 2 times the y. Okay, so here's the problem. I don't have y. But is there a way that I could find it with my given information? Well, this is just a right triangle, right? So I can just use Pythagorean theorem here. And if they're going to make me do this, they're probably going to give me a Pythagorean triple. Those you should know offhand. So like 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25. Those are really important triples. So 5, 12, 13, those are what I'm going to plug in as my height, my y. And then dy dt. Let's do a different color. Dy dt is equal to 0. Okay, so let's just finish solving this. Now, 2 times 5 is 10, times another 2 is 20. So this is 20 feet squared per second, plus 24. Oh, I forgot my feet here. 24 feet dy dt. Oh, we have to go on another page. Alright, it's a little cleaner here. So 20 feet squared per second plus 24 feet dy dt. I'm solving for that dy dt, so I'm going to subtract my 20 feet squared per second first to the other side. So I have 24 feet dy dt is equal to negative 20 feet squared per second. Alright, divide by 24 feet. And look what happens here. We have feet squared divided by feet on the bottom, so my units are going to be just feet per second, which is really good because I'm finding dy dt, right? And that's a rate. So if my rate is what I'm looking for, I want units that are going to match what a rate would be. So that's negative 10 feet per second, which totally makes sense because negative means it's going down. But the height of that ladder is decreasing against the wall. So negative 10 feet per second. Alright, so now let's justify using nut. So to justify it, I said the top of the ladder is sliding down the wall. That's my noun. That it was just straight from my question that I just restated. At a rate of negative 10 feet per second, so I have my answer with my units here. Here's my u. This was my n. And then when the ladder is 5 feet from the wall. So that's my condition, my time, or my when this is happening. So when it's 5 feet from the wall, it's going to be decreasing at a rate of negative 10 feet per second. So as I mentioned before, some common topics for related rates questions that you should look out for are ladders. So if you see a ladder, it could be similar triangles, it could be Pythagorean theorem, it could be trigonometry, SOHCAHTOA, to find the rate that the angle is changing. So like the angle that the ladder is with the forming with the wall, how is that increasing or decreasing as that ladder is falling? Another popular figure is the sphere. You need to know the volume formula and the surface area formula. The cones, you should know that volume of a cone formula really well. Cylinders, that one you should know pretty well because you also talk about it when we do area and volume in Unit 8. So those are some formulas that you absolutely have to know to really make your life a lot easier with those related rates questions. Now what you really have to look out for are the problems that you give a ratio of radius to height and they want you to solve for one in terms of another. So here's an example of that. This is a calculator allowed question. So on a construction site, gravel is delivered and poured into a conical pile. So conical pile, I know I'm going to be drawing my cone the best you can. Obviously, this is supposed to be done quickly, right? The diameter and the height of the cone of gravel are changing in a way that the diameter is always 3 times the height. So I'm going to write that down as diameter equals 3h. Now, we're going to talk about that in a minute. If the delivery truck is set to pour the gravel at a constant rate of 3 cubic feet per minute. So a couple of things give me the hint that that's volume there. First of all, I'm pouring into the pile, so I'm measuring the volume of the pile. Second of all, it says cubic feet. Feet cubed is your hint for volume. So cubic feet per minute is going to be my rate that the volume is changing. So my dV dt is equal to 3 feet cubed per minute. Okay, how fast is the radius of the pile changing when the height is 4 feet? So a couple of more information there. I know the height is 4 feet, and I know that I want to find how is the radius changing, so I want to find the rate of the radius with respect to time, so dr dt, and this is what I'm looking for. They gave me the formula. They told me volume is equal to 1/3 pi r squared h. So if I differentiate this, notice that the r and the h, that's going to be a product rule, first of all, but it's also going to be a problem because I know I'm looking for dr dt, but I don't know anything about dh dt. So that's where this d equals 3h, that's where that's going to come in. So first of all, there's no diameter in this formula. So let's change that to 2 times the radius is equal to 3 times the height. And I want to get rid of this h, so I'm going to put that h, I want to make it h equal so that I can have everything in terms of r. So I'm going to divide by 3 on both sides. So I can say that my h and rewrite it as 2/3 r. And then I have my r squared, my pi, my 1/3. And that's going to make my equation now be a little simpler to derive, first of all. And second of all, I won't have to worry about that dh dt. Okay, so now let's simplify this before we take the derivative. We have two fractions here. We have a 1/3 and we have a 2/3. So I can multiply everything across. That's going to become 2/9 pi. And then I have an r squared times r to the first power is going to be an r cubed. So I can change this to volume equals 2/9 pi r cubed. Okay, so now that I've simplified my equation as much as I can now take the derivative with respect to time. Take the derivative of volume equals 2/9 pi r cubed. I have the derivative of v with respect to time is equal to 2/9 pi r cubed. So I'm going to bring the 3 down and multiply it by 3 times 2/9 times pi r squared, which is going to simplify, and that's going to give me 6/9 when I do 3 times 2, which is going to give me 2/3 pi r squared. But I took the derivative of r, so I need to have dr dt, and I'll copy my dv dt. Okay, so once I differentiate, now I can just substitute in what I know. So I know the derivative of the volume was changing at a rate of 3 feet cubed per minute, and don't forget to put your units. And that was equal to 2/3 pi. The radius, I'm going to have to find from that formula 2r equals 3h, right, that I had from before. So I know that the h is 4, so this is going to be 12 equals 2r. So my radius has to be 6. So I have times 6 squared times dr, that's an r, make sure that's an r, times dr dt, and that's what I'm looking for, so I'm going to leave that alone. And then I'm going to use my calculator here. Oops, let's make that feet inside. Don't forget your units. So that's going to be 36 feet squared. So this is 2/3 pi times 36 feet squared. Dr dt is equal to 3 feet cubed per minute. And remember, this is calculator allowed, so at this point, just divide everything. You have your 2/3 pi times 36 feet squared on both sides, and we can see with the units that this is going to work out because I want a rate. I'm looking for that rate of the radius. So when I do my feet cubed divided by feet squared, I'm left with just 1 foot per minute left, which is going to be what I want. And when I put this in my calculator, I'm going to get 0.4040 is equal to that dr dt on the other side. So I'll write it over nicely here. Dr dt is equal to 0.040 feet per minute. Okay, so that one I believe is choice A on your worksheet.